A significant percent of the total 340 million customers use SBI banking and mandate systems every day. Presently, a check takes at least 1.5 days to be cleared. How convenient would it be if the mandate was validated instantly within the bank, taking the same time as that of a card transaction? Well, my father runs a small business and he said this will certainly make his life a lot easier. So let's talk about how this could be done. Presently, mandates are manually verified. A lot of improvements can be made in the existing system. The whole process can be automated to achieve sub-millisecond turnaround times and superhuman levels of accuracy with minimum human intervention.
In the past few years, there have been tremendous development in the field of machine learning and artificial intelligence, especially deep learning. Now this has allowed our phones and many other systems to be smarter and more capable than ever before. But still there are a lot of large-scale operations, for example the current mandate validation system, that still require a lot of manual work. Now this type of work can be very much eased with the help of automation. So hi, we are Team Not Boring and we present to you our solution AutoSign.
Recent advancements in deep learning has enabled systems to make sense of image or data streams to recognize temporal and spatial characteristics. It can easily recognize if it's a cat or a dog, or even recognize the specific breeds of them. It can even figure out what's going on in an image, like for example the cat is playing with a ball or so on. Now classifying whether an image contains a signature and actually validating if two signatures are the same or not are two completely different problems for a neural network. But it can be accomplished using very similar paradigms. Normally a deep convolutional network takes as input an image and we train one specific network to output positive results for one specific class of objects in the image or even multiple classes. This is done by understanding the underlying features of the image. Like at first it looks for small features like its curls, etc. And then it looks for combinations of those features represent some higher dimensional features like the structure of a face or body. These are not human understandable features but rather some high dimensional complex linear combinations of them. Now in the case of signatures, we train the network to give similar set of feature vectors for same signatures and totally different feature vectors for dissimilar or fourth signatures. This is similar to cryptographic hash functions where same inputs produce similar outputs and a slight variation in the inputs completely change the outputs. This increases the security of the entire system as the signatures can't be obtained in any way from the feature vectors extracted by the neural network. Thus, when the feature vector is sent from a central server to the bank, it is completely immune to man-in-the-middle type of attacks. Even if a bad actor gains access to all of the source code and the model, there is no way to get signatures from them.
This approach is significantly superior in accuracy and is the current state of the art in offline signature verification. A similar approach is used for facial verification in security systems across leading startups across the world. The main benefits of Siamese networks is that we don't need more than 2 images per person to train and is a one-shot learning method. Transmitting feature vectors over the network not only minimizes bandwidth usage but is also highly secure when compared to transmitting raw image files over the network. This is because the image is vectorized with a one-way function which is learned from the data at hand. This function is basically a cryptographic hash function. Thus, the function can't be inverted to find the original image. This is equivalent to sending encrypted data over the network. Content delivery networks at the branch level can be used to store and cache the feature vectors, thereby enabling minimum latency response. This fully automated system results in greater customer satisfaction, more efficient use of human resources in the banking system, and most importantly, less time to validate the mandates. This will lead to greater productivity and hence bigger turnovers for the bank. The main problem of this approach is that it is computationally very expensive, especially when we are training the neural network. To achieve real-time performance, specialized hardware like GPUs need to be provisioned in the system. The accuracy mostly depends on how well we train the network, so the system will improve by leaps and bounds over 4 signatures go through it. Adversarial examples are the best way to make the system more robust. Now, let's talk about us. Why we think you should trust us with this responsibility. We are a highly motivated team of people and are passionate about our work. We are mainly interested in intelligent systems and their applications, and we ourselves pursue research in these topics. We are well acquainted with recent developments in both the industry and academia in machine learning, and we love to build real-world solutions based on our knowledge. We also are working with various open source organizations and contributing to their code bases.
We are Team Not Boring.
I am Orbo.
I'm Vibhuti.
I am Moyan.
I'm Shayan.
We really would love working in this project as adding enhancement to a live system used by millions of people daily is just the kind of challenge we dream of. Finally, thank you so much for this amazing opportunity. We look forward to impressing you with our work.